All right, so today our goal today is to talk about algebraic notation. Let me hide these really quick so they're not distracting. There it is. Okay, so our goal today is to talk about algebraic notation and really get started on some algebra. So depending on how much you've been exposed to this, you may need me to slow down today if you're just not quite hanging with me. This is a really great day for you to practice raising your hand and just saying, Mrs. Jergens, I'm just going to need you to rephrase that or go back over that again. Okay, so that's fine. All right, so we're going to talk about patterns today. We're going to talk about some terminology, and then we're going to talk about how to write algebraic expressions. I'll move over here. Can you guys all see the board? Yeah? Okay, if I'm standing here, can you see it, Declan?
Yeah.
All right, perfect. Okay, so let's walk through a pattern really quick. All right, so we've got Vivian and Maya right here, and this is in your notes. Go ahead and turn to the next page in your notes. So you will be taking notes as we go through the PowerPoint today. And you'll know you need to take notes when you see a blank spot in your notes pages for you to fill something in. You have a quick question, Declan?
Yeah, I can't see like the bottom of the screen. Would you like to scan again?
I'm sorry. Let's just put that over there.
Yeah.
Okay.
Thank you.
All right, so we've got Vivian's age and Maya's age, right? When Vivian is 6, Maya is, when Vivian is 7, Maya's, when Vivian's 9, Maya's, when Vivian's 12, Maya is, when Vivian is 15, Maya is. Okay, so hold up. How many more years, let me rephrase that. That was so awkward. How much older is Maya than Vivian? Tommy? She's 2 years older, right? So anytime, like if we know Vivian's age, we would add 2 and we would know Maya's age, right? Okay, what if we don't know Vivian's age? Okay, Michael, you want to comment on that? Yeah.
Well, it looks like it's a pattern. It goes 6, 7, that's +1, 7, 9, that's +2, 12, 15, that's +3. So
okay, that's cool that you noticed that. Yes, this is a pattern.
So I kind of assume that the end is 19.
We don't have that information though. Like we don't, there's no like secret information behind this. It's just N means we don't know. N means we don't know how old Vivian is. But we do know that Maya's always 2 years older than her, right? So algebra would give us a way to write that down. If Maya is always 2 years older than her, I think this is my next slide here. Let me look. Nope. Okay. If Maya is always 2 years older, the way that we would write Maya's age, and write this down with me, would be this. She is Vivian's age, which N is standing for, plus 2. Sorry about that. Sometimes my electronic pen does weird things, like it'll just randomly draw a line. And that's how we would write it. Maya's age is N plus 2 because she's always 2 years older than Vivian. So in that case, the N stands for Vivian, N plus 2 stands for Maya. Is everybody hanging with me so far? That's not too hard to picture, right? Okay, we just don't know how old Vivian is, but Maya's 2 years older. Declan.
If we know that Maya's 2 years older, can't we just add 2 to the 15 and that would give us Vivian's age and then add 2 to that to get Maya's age?
No, because we don't know what this N stands for.
That's what we'd be finding out.
We can't. We don't have enough information right now. So yes, I agree that I agree that there is a pattern here, but let's say we had used different numbers. Let's say that instead of +1, +2, +3, +3, let's just say it was completely random on my table here. And I said Vivian's age was 5. Then Maya's age would have been 7. Vivian's age is 10. Maya's age is 15. Vivian's age is 6. Down here, Maya's age is 8. Vivian's age is 72. Maya's age is 74. Do you see what I'm saying?
Yeah.
So there is a pattern, but in this particular table, the pattern doesn't mean anything. We cannot use that pattern to determine what N is in this case. Now, if we had Maya's age, if we said Maya's age now is, actually we do know Maya's age and she's 20, how old would Vivian be?
It'd be 18.
Yeah, Vivian would be 18, but we don't have that information. So we just have to say Vivian is N years old. Or Maya is N plus 2. This is called an algebraic expression. An algebraic expression just shows us some math that we can't do, basically, right? So it shows us a formula that we could plug a number into and solve later, but we don't have enough information right now to solve that. Okay, so on your next slide, underneath that table there, we're going to do some fill in the blanks here. N stands for any whole number and is called a variable. Variables can be other letters than N, by the way. They can be X or Y or Z or A or any letter from the alphabet. Those are called variables. Let's make sure we're all practicing good note-taking habits today. So just a reminder, in math, you're going to take notes on everything that you see up here. All right? And it's red, so that makes it easy. A variable is a symbol that represents an unknown quantity. Okay? What formula did we use to express Maya's age just a moment ago? What was that formula? Mira?
It was in parentheses N plus 2.
It was N plus 2. Great job. And we did put that in parentheses because I added a label, years. And I'll explain while we're using the parentheses in a little bit, so that'll become clear. Okay, so we're going to copy that down on that last blank on that slide. Okay, ready to move on?
Yes.
Great. N plus 2 is called an algebraic expression. It contains an unknown number represented by N. When the value of N changes, the value of the expression N plus 2 changes accordingly. Mr. Jurgens is 3 years older than I am. What's an expression for Mr. Jurgens's age? Let's just assign N to my age because I'm not going to tell you the real age. What is, how old is Mr. Jurgens? Piper? Yeah, N plus 3 years old. Great job. Okay, we got that? Okay. Let's write some algebraic expressions. We're going to start off with numbers to make it easy. Do you need to grab your pencil? Somebody's pencil went flying. Do we need to grab something? Okay. How can I write an algebraic expression for the total of the book and the notepad if I were to buy those together? Well, let me just ask you this. Before we come up with the algebraic expression, I want to buy a book and a notepad. All right, let's start with this top line. I get to the checkout stand. How much do I pay for the book and the notepad together, you guys? Lucy, yeah, say it out loud. Yeah, that's pretty easy, right?
Yeah.
What did you do in your head when you just said 7? Uzziah?
And then it's just like 4 plus
3. Oh, you did 4 plus 3. So that would look like this, right? $4 plus $3. Okay, great. Let's write that down. Yep. Okay, now I don't know how much the notepad costs. So I get to the checkout stand. Can you tell me how much I'm going to pay? If I don't know how much the notepad costs, but the book still costs $4. Let's say this is a different store. Cameron?
4 plus 3.
Yes, great job. To write that total, we would write $4 plus N dollars. Make sure you guys are copying down the dollar sign, then I'm going to give you an alternate way to write that in just a second. Declan?
But wouldn't you also be able to swap them? Like, not if you needed to, but Wouldn't you also be
Mhm.
able to swap them for multiplication?
Because addition?
Yeah.
Yep, because addition is commutative. Yes. So we can swap those around in addition. All right. Now, when we get to other operations, not so much. Okay. But when we're adding terms, whoops, sorry. Let's go back there. When we're adding terms, when we're talking addition, we can swap the terms around. Okay. Now, what if I don't know what the book costs, but I do know that the notepad costs $3? How much do I pay at the checkout? Cecilia? Exactly. B plus $3. Okay, I'm going to give you another way to write this. That's a little bit fewer. I don't know if it's less steps or not, but maybe you like this way better. So we either need to write B dollars plus $3, for example, so that the dollar sign applies to both of those terms. These things in the algebraic expression, these are called terms. Or we can write it like this. Dollar sign 4 plus 3, write these down with me. Dollar sign 4 plus n in parentheses, or dollar sign b plus 3 in parentheses. What the parentheses mean is that whatever is outside of the parentheses gets distributed across all of the terms in parentheses. Does the way I phrase that confuse you at all? No, good, because you guys, when I said gets distributed, you guys thought distributed property and you're good to go. Awesome. You guys are awesome. Way to go. Okay, do we have this? Anybody stumbling at all with what I've covered so far? We're good to go? Okay, this is the same thing. We're gonna just keep going. All right, so let's do some problems. These next few problems that we're gonna go over, we are gonna draw some bar models as well as write the algebraic expression. Let me get myself a little bit reorganized here. I've kind of got much stuff on my stand. Okay, can somebody read this for me? Go for it, Shafiq. Eyes up here. Thank you. Okay, so let's go ahead and start with the bar model. Okay, we are going to start with his total, which was 35. Anybody recognize this type of bar model? Do you remember what this is called? Tristan? Is it a comparison or part whole? It's a comparison, okay. Whoops. Okay, thank you. Okay, so he's got 35 and he loses 8, right? Okay. How many does he have left? This is the space that we're looking for, isn't it? We could also draw it like this. He had 8 and he wanted, that would be a part whole.
Yeah.
Yeah, it doesn't, we can do both, either of those types of bar models there. How would we find the answer to that question mark, folks? This is a pretty easy problem, right? I think you all know what to do. And I bet you can all tell me what operation I'm going to use next. Owen, what would you do? Yeah, and what would that give us? Exactly. So to find my answer, I would do 35 minus 8, and that would equal 27 what? Marbles. We want to make sure we include the label there. Okay, so now we know how to do that type of problem, right? Make sure you copy all of the things that you see on the slide, guys. So including the 35 minus 8 equals 27 marbles. Got it? All right. Let me give it about 5 more seconds here. And this is important because even though this is a super intuitive problem that I think everybody in here knows how to do, we're going to jump to the next slide that says now Ben lost X marbles. And we're going to write an expression for that. So Ben had 35 marbles. Let's draw our bar model again. Should we do a part whole this time?
Yeah.
Let's do that. He's got 35 marbles and he loses X marbles. How many marbles does he have left? Can we figure out how many marbles he has left if
No,
we don't know X?
no.
Nope, we can't. But can we write an algebraic expression?
Yes.
Yeah. Anybody want to guess what our answer would be? Like, how would we would write that algebraic expression right there? Landon? 35 minus X, and then what would we say? We just need a label. Yeah, 35 minus X marbles, and this is how we would write that. Give me a thermometer. So this is like, I'm not getting it. This is, I'm hanging in there. This is like, let's crank up the speed. I'm waiting on all my thumbs. Okay, nice. Okay, I like it. All right. Anybody need me to go back over that one again? Okay. All right, so let's do another one. This time, Ben has M marbles. Okay, we're repeating our bar model here. So now this time, we don't know how many he starts out with, but he loses 8, and we want to know how many he has left. Okay, so things have changed now. How are we going to write an expression for the number of marbles Ben has left now if we don't know how many he started with? Kristen? Yes, great job. M was the total that he started with. We'll do M minus 8 marbles. Because the whole that time was M, he lost 8 of them. So to figure out how many he has left, we do M minus 8. Declan?
Maybe writing a sentence at the bottom.
Not for this. No, for the answer, it's M minus 8 marbles.
Oh, okay.
Yeah. Okay. So here's a little tip for you. Did you notice how when I taught you guys how to write both of those addition and subtraction algebraic expressions, we started off with a situation where we had numbers instead. And was it super, super, super easy to figure out what the answer was when you had a number? All you have to do is stop for a minute and think in your mind, like, what did I just do right there? I did 4, remember our book and notepad example was like, oh, I added 4 plus 3, right? So we had to back up for a second and say 4 plus 3 equals 7. Carter, if you need to back your chair up so that you're out of the sun, please go for it. Or you can use my desktop if you want to, or whatever. So that's the thought process. You need to like just slow down and think about, what am I doing? What's the operation? Eyes on me, guys. What's the operation? And how do I do this with something that I don't know? So here's my tip for you guys, and this is in your notes. If you're trying to write an algebraic expression for a variable, substitute a number for the variable first, and then change the number to a variable. For example, Tracy bought 10 kilograms of flour and she used 5 kilograms for it. How much did she have left? You know, without even, thinking about it, she's got 5 kilograms left, right? But let's say your word problem instead told you Tracy bought X kilograms of flour, or W as it is in your notes. She bought W kilograms of flour and used 5 kilograms of it. How much did she have left? It's not as obvious then. So you would substitute whatever variable you're given in the word problem for, or a number for whatever variable you're given in the word problem. Yes, Mira? Mm-hmm. You won't, yeah, you're not going to have that on your homework today. So don't worry about it. All right, go ahead and do that next one. See if you can draw a bar model and write an algebraic expression for this next slide that's talking about Riley and Nate. Once you're done, go ahead and put your pencil down so I can get a visual of who's still working. All right. Does anybody want to share what they did for that first one? Okay. Okay, Kylie, go for it.
Should I do the math problem analysis?
Yeah, why don't you show us what you did? Okay. Actually, can you read it out loud for us first?
Yeah, I did the bar model like as one
Read
bar
the
model.
problem all out.
Riley had 50 beads. He gave K beads to his friends. How many beads did he have left?
Okay, go for it. You can go ahead and draw what you have. All right, so Kylie's going to draw us her bar model first. And you can explain while you draw if you could draw and talk it. All right, that looks really good. Can you talk through your solution really quick, Kylie?
I did 50 minus K beads.
Yeah, good. And your bar model looks great. You showed that she started with, or he gave K beads to his friend, but he started with 50. Who thinks they have a second one? I'm sorry, let me slow down just a second. How did we do on this one? Yeah, we did okay? Yeah, Morgan? Sure. You're confused on the bar models. Okay, let me see how you drew it. Your bar model looks basically the same, except that your K is in the other. Oh, no, it's not. You've got your 50 here. So the reason we would put the 50 at the top is because it's the total. Does that make more sense? Because he started with 50 beads. So we need like the whole to show 50. And then part of the 50 was the K beads. Does that clear it up a little bit? Okay. Any other questions on that problem? Let's do the next one. Nate ran 3 miles on Saturday and X miles on Sunday. How many miles did he run altogether? Who's got it? Who's got it? Kylie. Okay. That looks great. Okay, so why don't you show us your solution and talk through it too?
So, Nate ran 3 miles on Saturday and X miles on Sunday. How many miles did he run altogether? He did slow. Oops.
Oh, I know. You just swipe it like that.
I did the bar model first. What? Shoot. So we don't know this.
Okay.
And he ran 3 miles in X miles. So 3 X.
Nice job. No, that's great. It's kind of hard. Okay, I'm going to make one little correction to your solution, okay? And the only thing that I'm going to correct is we're going to take away the equal sign because we don't know what it equals yet, do we? So with the algebraic expression, we don't include an equal sign. And one common mistake I see kids making is like, they'll say something like 3 plus X miles equals like Y, or they'll just come up with another variable. We don't do that. This is just an algebraic expression. So let's contrast that with something else we're going to talk about, which is called an algebraic equation. Everybody here has heard the word equation before, right? What does the word equation have inside of the word? What does it have in the word? McKinley? Yeah, it has an equals. So with an equation, we do include an equal sign. With an expression, we don't, but this was great. Very well done. Thank you, Kylie. Okay, I think that that's kind of a good place for us to stop. Right now, we're going to stop before we get to multiplication and division. So chill for just a second, and I'm going to pass out another little procedure thing that we need to go over before I pass out homework. And so you guys have another day at least to study those procedures in the front of your packet, because we're not going to do that today. We're not going to do the quiz today.